Alright, so this is question 3 of the week 6 sprint handout, and it says, what is the area of the triangle with vertices at 2, 2, 4, 5, and 7, 5? And we need to express our answer as a decimal to the nearest tenth. So to solve this problem, we need to be using this theorem called the shoelace theorem, and I cannot even begin to describe how useful this theorem is. What this helps you do is if you have the coordinates of any polygon, you can find its area, which is super cool. So let me show you how this works. So first, what we're going to do is we're going to take any coordinate. In this case, I'm just going to take 2, 2 since it's the first one. And then we'll go to the next one, 4, 5, and then 7, 5. And then you repeat the first one. You repeat the coordinate you started on, 2, 2, and you just arrange them like this. Now, the order in a triangle that you arrange these coordinates doesn't really matter. But if it did have more vertices than a triangle, it would matter. And the reason for that is because the coordinates need to be arranged going in one circular direction. So they can either go clockwise or counterclockwise, but the thing is triangles only have 3 coordinates, so it's not possible to, like, let's say you had a hexagon, you couldn't arrange your coordinates like this, but that's not possible in a triangle since, you know, you can only literally arrange them either like that clockwise or like that counterclockwise. But if it were any other shape, you'd have to make sure that you are going in one direction when you're arranging your coordinates. Anyway, so what you do next is after arranging these coordinates like so, you multiply them diagonally and you make sort of like shoelaces. So that's why it's called shoelace theorem, because you have 2 times 5 is 10, and then 4 times 5 is 20, 7 times 2 is 14, 2 times 4 is 8, 5 times 7 is 35, and then 5 times 2 is 10. And this is a little hard to see. Let me draw little lines here. So as you can see, these little crosses in the middle make it look like kind of like shoelaces in a boot or something, and that's why it's called shoelace theorem. But now what you do is you add up the numbers on both sides. So 8 plus 35 plus 10 is equal to 53, and then you subtract the numbers on the other side. So 10 plus 20 plus 14, that's equal to 44. And then what you do is you take the absolute value of that and you divide by 2. So in this case, this would be 9 divided by 2. And so our answer is 9/2, but it wants it as a decimal to the nearest tenth. So this will be 4.5. And this is how finding the area of any polygon using shoelace theorem works. So there'll be some extra practice in the handouts, and this is super useful, so remember it.